Drawing from Waves Basic. Wave frequency is the amount of waves that pass a certain point in a certain amount of time. Wavelength is the distance between the crests of two waves. Wave amplitude is the height of the wave. These images show a change in frequency because there are only two waves in the space of 1 second in the first picture, and there are 3 waves in the space of 1 second in the second picture. Therefore, frequency in the second picture is higher than the frequency in the first picture. These images show a change in wavelength. When I played the duck ringtone through a cup telephone on a string, there were 17 sound waves, and the duck ringtone without a cup, there was 14 sound waves. But they had the same amplitude, which means their wavelength was different. The material used on a telephone on a string does impact its effectiveness as a communication tool. According to my group's calculations, most people would automatically think the styrofoam cup is the best because of its high average of 1.28. However, the styrofoam cup's average is lower than its uncertainty of 1.64, making it completely inaccurate and therefore unreliable data. The paper cup, on the other hand, has the smallest average of 0.366 compared to the remaining reliable data of plastic cups, which has an average of 0.3433. But an uncertainty of 0.335, which means the distance between the plastic cup's average and uncertainty is greater than the distance between the plastic cup's average and the paper cup's average, making the paper cup the most reliable data, therefore the best to use. Now we can conclude the paper cup is the most effective communication tool. Frequency increases as energy increases. In the visible electromagnetic spectrum, purple has the highest energy, and red has the lowest. This also means that purple has the highest frequency, and red has the lowest frequency. Television produces radio waves, and 100,000 X-rays are the size of one piece of paper. We can use absorption and emission spectra to help identify objects by identifying either the absorption or spectrum or emission spectrum of a material and matching them up like a puzzle piece to find out which absorption and emission spectrums line up, and use the previously identified spectrum to find out what the material is. A sonic boom is an extreme case of the Doppler effect because when an object is traveling at over Mach 1, the sound waves still travel in a circle starting from the object. However, since the object is traveling faster than those waves, the wave frequency is amplified so much that the sound of the waves collide with each other, creating a sonic boom. When an object accelerates, the motion blurs the light, making it appear differently, which causes the color to seem to change. The reason the laser can bounce off these two mirrors to hit the target is because of reflection. A reflective surface like a mirror captures the light of an object in front of it and reflects it, mirroring the light. This also explains why the baby is mirrored. Moving on, this angle allows the angle of incidence to be reflected into the angle of reflection, which we use to determine where to place the second mirror and reflect the laser off that mirror to hit the bullseye. The reason the duck looks so deformed is because of refraction. The speed of the light is entering the water bends the light wave, making the duck's leg and underbelly look larger and out of place.